Okay, tied in to this section, if you're looking over the book, you probably saw they have something they called solving by factoring. Now, here's some terms that mean the same thing, so you're not confused when you see this. They'll refer to the solutions of a function, or the roots of a function, or the zeros. All three things mean the same thing, and different books at times may use one or more of these terms. But understand, if they say find the solutions or the roots or the zeros of a function, that these three things are the same. And solving by factoring is the preferred way to solve. It's probably the easiest. We'll learn a couple other methods. Now imagine this. You want to know what would make x plus 3, x plus 5, the quantities multiplied, equal 0. Well, just think conceptually. You're actually multiplying this times this. So if either this is 0 or this is 0, when you multiplied them, it would turn the whole thing to 0. Just as if you had 0 times 56, that's equal to 0. Or if you had negative 23 times 0, that would be equal to 0. That's the concept of what we're doing here. That doesn't relate directly to this problem. It's just explaining the idea that if either is 0, it will be equal to 0. So what you ask yourself is, what value could I put in for x to make x plus 3 equal to 0? Well, in this case, it would be pretty easy to look at it and say, well, negative 3 plus 3 is equal to 0. And negative 5, in this case, what makes x plus 5 equal to 0? Negative 5. So the solutions are negative 3 and negative 5. So what we had here is we had a form that was already factored, so we didn't have to show the factoring step first. So you found what is known as the solutions, or depending on your text and use, they also refer to them as the zeros or the roots. They all mean the same thing. Okay, here's another one that's already factored. What value could I put in to make x minus 7 equal to 0? Well, 7. What value could I put in here to make x plus 4 equal to 0? Negative 4. So your solutions are 7 and negative 4. And one more that's already factored, and then we'll make u factor first and find your solutions. Now you're actually multiplying x times x minus 9, so one solution would be simply 0 if x is equal to 0. And your other solution would be, what minus 9 equals 0? Well, 9. So your two solutions are 0 and 9. Okay, now what you're going to have to do is you're going to have to factor and then just take this extra step. Now you learned about factoring in the last section. Two numbers that when multiplied give you 20 and when added give you 9. And what would make each set of parentheses equal to 0? Well, negative 5 plus 5 is 0, and negative 4 plus 4 is 0. So those are your solutions. Okay, factoring the next one, we have to have one positive and one negative. So they have to multiply and give us negative 18 and add, give us negative 9. Well, let's see if there is anything like that. If it has to be one positive and one negative, Okay, so if we add these up, none of these will add up to -9, so this would be not factorable. Sometimes I use the word prime. So anything that's not factorable, we'll have to learn another method on how to find the solutions. Okay, we'll try this one. Two numbers when multiplied give us 28, when added give us -11. Hopefully you had enough practice in the last section to recognize that it would be -4 minus 7. -4 times -7 is +28. When you add, you get -11. What makes this equal to 0? 4. What makes this equal to 0? 7. So those are your solutions. Okay, the last example we'll talk about on the next page, because the only factoring we can do here is greatest common factoring. So now, as we learned difference of squares in the last section, we learned this factors into x plus 5, x minus 5. And what would make x plus 5 equal to 0? -5. And what minus 5 is equal to 0? 5. Now, the next one isn't in difference of squares form, but one simple step will get it there. If you subtracted 81 from both sides, you would have x squared minus 81, and that would factor to x plus 9, x minus 9. So your solutions, what plus 9 is equal to 0? -9. What minus 9 is equal to 0? 9. So there are your solutions. Okay, again, back to our final example. This is one where you only have a greatest common factor. And when you get the greatest common factor, you got to look at both the number and the variable. It looks like the number portion of our greatest common factor is 3. And take the lower value of x squared and x, which is x. So your greatest common factor is 3x. 3x times what is 3x squared? X. 3x times what is 18x? 6. So you're now factoring. Again, you're multiplying this times this. What would make 3x equal to 0? Well, 3 times 0 is equal to 0, so your one solution is 0. And what plus 6 is equal to 0? -6. So those would be your solutions. And again, your solutions, if you plug them back in to the original function, would give you 0. If I plugged in 3 times 0 squared plus 18 times 0, it would be equal to 0. If I went 3 times -6 squared plus 18 times -6, yes, that would also be equal to 0. Just like back here, if I went -5 squared minus 25, that would be equal to 0. 5 squared minus 25 would be equal to 0. So we're just taking factoring a step further and finding the solutions.